to introduce or present something about the automated non-functional requirement testing by using a continuous integration environment. This is my research topic anyway. So we first start the agenda today. I follow the generic guide. Like first I'll present the research area in a short or general. And then it's about the research progresses so far we have done. I will also present some findings about the research studies, follow up by the research plan. In the end, it's the courses which I have completed so far. So first it's into the research area as NFR testing and CI. So I have a generic or several NFRs, types of NFRs here, and also highlight the comparison between functional requirement and non-functional. So the key things is what I want to show here is the functional part is about what exactly the system does. Non-functional is more about the constraints on how the system fulfill the functional requirements. And it's one is for use cases, former use cases defined, and normally at component level. The latter is on the quality attributes and almost applied to a system as a whole. So that's the basic differences which I can see. And that could explain what exactly NFR. NFR is the qualities of a system or system abilities, and it's how the system fulfill the functional requirements. And why the NFR are critical? Because they are actually essential for developing high quality software. If a software system or a system doesn't meet non-functional requirements, it can probably continue to perform its basic features, but for most of cases, of some cases like user privacy, it doesn't met, and then it's not really okay from a non-functional requirements perspective, and it won't be able to provide a great user experience. For many projects which I have seen before, because I am a developer, the NFR issues like the NFR scope or the conflicts, example, among the NFR types are found very late. Sometimes they are even in release stage, which could cause negative impacts to the development plan or the agile iteration. So why we introduce CI in this case for the NFR testing? Because the CI is good at integrating software and evaluate the quality attributes by using integrated tools today or plugins, and which can prevent errors slipping through the development stage to later. Potentially it could save cost in this case. CI, through our study, we find that CI can play at least two roles: as a supporter or as an enabler. Supporter meaning our refers to providing inputs or some prerequisite for the test automation, the builds or the jobs. And the enabler specifically refers to making the automated test, NFR test, possible. And also we could replicate the test flows to different project or components. The progress so far we have done, the first one is the in this research area, explore into the existing literature. So that one has been published in 2020 to IST. Second paper is we we have the literature result. Then we are trying to verify the literature result or findings in industrial context. Then it was a multi-industrial case study. Unfortunately, this paper was rejected twice. Now we are working on a rejoint on third round. That takes quite long time. In parallel, we have communication of ACM where we could, present the industrial practices, which include reactions from practitioners, challenges, and the guide for practitioner in industry, so they could get benefits from their study. I'm going to talk about some findings. In general, the first paper, we find a baseline for the CI-based NFR testing. For the second paper, we find, because it's industrial case studies, and we find in industry context, the CI environment can support and enable NFR tests. Third paper, it's basically the practices or action challenging things summarized in a communication of ACM. So this is the baseline we find through the academia side. In the middle layer, 3 layers in general. In the middle layer, we have the CI components, which extracted from the publications. On top layer are the available tools, at least in 2018. Before that, we find that those tools can be applied in different components. In the bottom are the NFRs, which potentially can be mapped to individual CI components. So before we dive into industrial findings, we just draw the baseline view in this part, which could help us to compare the industrial result to the academia finding. So first project is the project A. The red lines are the missing part compared to our baseline, and the blue colors are the tools which has been adopted in project A for the NFR security and performance testing. So here they have the security and performance test cases stored in Gerrit and Jenkins trigger test, and the artifacts pushed to JFrog Artifactory. So and they're using the VMware resource pool to handle the test slaves, let's call that. So that's the first project. And second project, it's actually implement basically all the components we have found from the academic side, and they have been adopted for this setup to test 5 types of NFRs, and it was working well. Maintainability, I just highlight that maintainability part, or security and the maintainability, they cover two levels. First, in source code level, that's being covered by the SonarQube, and then the system level, it's running the test cases in the VMware virtual machines. So it requires the system being deployed in a VM or in a cluster. The others, they don't have the static code covered, but it's the test cases in there. It was to mention that stability and scalability there, it's a semi-automated, meaning they need to manually trigger that. So they have a job which helps people to trigger that if they before the release candidates is generated. The third project is quite small one, so you can see they have actually 3 parts are missing, and it's very small team actually. So basically, you can store their build artifacts locally, and 3 or 4, I think. They can directly communicate to each other. So they only evaluate the performance perspective on assistant performance for the NFR aspect. But yeah, it's worth to mention they use different tools compared to the previous 2 projects. They use the Bitbucket, I mean a different one to manage the source code and the version control. Fourth one, it's setup. It's quite familiar with the or similar with the project A actually, but they're using different tool in here. They also cover the security and performance. The last one, it's quite big. However, they only evaluate performance based on the data we collected through the interviews. Yeah, as was mentioned, we executed 22 interviews with the participant from the industry. Yeah, so that's why all these participants stated that they only have performance has been evaluated in this CI setup. Okay, that's the result we find in general. CI can support and enable NFR testing. The benefits, it's the automated test can reduce much manual steps because, for example, I have seen before, there are like 30 or 40 pages to document how to configure the system, how to run the installation, how to run the upgrade, for example, and those can be automated. For developer and testers, we could get faster feedback through the CI for NFR aspect, verification and validation. Another interesting finding, I think, is worth to mention here. This kind of setup can achieve NFR testing for code to release. We found example in project B only, I think. So they basically add a unique ID in every single Git commit in the header, in the beginning of the header, then could track. So the CI will check out that commit and then run the related test. When this gets failed, and they will report automatically to issue tracking system, meaning here like Jira. Then the issue can be monitored if it's in progress or a review or down like that. So, and then meanwhile, the Jenkins can create the release note by include the ID, the use cases, the NFR use cases in the release note. And then, so it can be included in the release candidates in the end. Cost, yes. So we have 2 areas of cost. One is the implementation cost. Here refers to the test case implementation. For example, you need to implement performance test cases if you don't have any, tool which automatically enable performance testing. I think not many tools can do that. So for most of the cases that we have studied, they have their own test cases implemented. Another part is maintenance work, because CI have so many components integrated. Then we need to maintain the CI environments working well to execute, trigger, and the resources. So quite a lot of maintenance work for that. Challenges is since we're using CI for the NFR test, the stability is the top challenges. Because sometimes we observe that the test cases got failed, but it's difficult to distinguish if it's a only environment issue or it's really bugs in the code. So that's it's a challenge. And then we ask, or through our study, we wonder if it's more components applied in a CI environment are good or better. The answer is no, because more components get on board in a CI environment, and then the complexity of the CI configuration and operation and maintenance become increased. Then it's meaning more cost and could impact the test result for many cases. And then also we find that there are lacking tools to evaluate several types of NFRs. For example, we don't have specific tools like the usability, like the portability, the interfaces. That's so it still requires more tools implemented or supported by the CI aspect. The plan. So the current plans, we're trying to finish up the ongoing 2 papers because it come to the end. We will finish up the rejoinder, and then we will finish up the communication because the writing is done, and then we just need to put the server result in the communication ACM paper. Next step is we plan to dive into the CI components individually, and we use the metrics in the CI components to collect data from the NFR. Then we could use those measurement data to monitor NFRs. But there we could probably have more investigation the NFR trade-off, because for some cases we have noticed if you increase a lot of security, but performance could goes down. But how far it goes down is acceptable. That's we need to think about. At least it's good for developers should understand when they, for example, add more encryption or the authentication check. Then they need to aware how the performance goes for their system. And also we plan to use some we will check there to smart alerts on the quality of a system. Here the alerts could be security level changed, and the case could be we could use the could be the machine learning algorithm like anonymous detection, like the advanced alert, or could be some other method in here. Course progresses. I have finished this list of courses. The latest one is empirical data statistics, mostly using the machine learning algorithm for that. And another implementation course for the NFR testing in CI environment. There we adopted a Kubernetes cluster and deploy all the CI components in there into a big package. And then we could onboard more machine learning modules in there, continuously collect data, continuously generate and predict the trend inside the environment. That's all for this session. So if you have comments or questions, welcome.